So that could show up again. Number 16. I want you to find the tangent of 5 pi over 12 using a half angle identity. How many degrees are 5 pi over 12?
75. I think he's right.
It's 75, right? So yeah, you're both right. It's the tangent of 75 degrees, so they're asking for the tangent of 150 degrees over 2. And the tangent formula from yesterday was
1 minus sine.
they're both cosines. It's always cosine on these half angle identities. Where's the plus go? Where's the minus go?
Minus on 12, plus on the bottom.
And Tim and I double checked, so that's correct. That's the easiest mistake to make on these. All right, what is the cosine of 150 degrees?
Negative 3 root 2. Or negative root 3.
Yes, I'm going to go back and write in the plus or minus again here. So we're not sure yet. Well, we think we might know. Well, actually, 70. So we're looking at the tangent of 75 degrees. Is that going to be positive or negative?
Negative. Or positive.
75 degrees is in what quadrant?
First.
First, okay? And everything is positive in quadrant 1, so we don't have to worry about the negative. Once again, Tim, what's the cosine of 150?
Negative root 3.
Negative root 3 over 2. So I put root 3 over 2 into negative root 3 over 2 into the numerator and the denominator, and this gets me the square root of 1 plus root 3 over 2 divided by 1 minus root 3 over 2. Is that in a nice simple form?
No.
No. Complex fractions, irrational all over the place. Let me see if I can do this across the bottom clearly. First thing, I want a common denominator, so I'm going to make that 2 plus root 3 all over 2 divided by 2 minus root 3 all over 2. 1 can be written as 2 over 2. 1 on the bottom can be written as 2 over 2. Then I can combine them. Once I have the same denominator, top and bottom in a complex fraction, what can I do? Same denominator.
You can cancel them out.
If I flipped it, they would cancel. If I multiplied by the reciprocal, I can just get rid of it. And now I'm down to the square root of 2 plus root 3 over 2 minus root 3. Even though we're under a radical, I still don't like that radical on the bottom there. So I'm going to multiply top and bottom by the conjugate expression, which is 2 plus root 3 top and bottom. That is to get rid of the irrational on the bottom of my fraction. The top is going to be like foiling. I'm going to get 4 plus 4 root 3 plus 3 over 4 minus 3. My a minus b, a plus b will give me a squared minus b squared. So that's going to give me the square root of 7 plus 4 root 3 over 1. You don't need to write the over 1. And that is the tangent of 75 degrees. So my final answer would look like the square root of 7 plus 4 root 3. You could also find that by using our sum and difference formulas to do the tangent of 45 plus 30. Your answer would look very different. And again, I might put those two questions on the test, find it 2 different ways, and then prove it's the same for extra credit. So that might be something that could help you guys out. Any questions on this one? You guys okay with these?
Mm-hmm.
All right, then I'll skip 18 for now, unless someone has a question, I'll come back to it. And I'll jump to the next section.
We have to show our work, right?
Oh God, yes. Yes, it's a good thing. It's a good habit for you to get into anyway, Nate.
He can't give you partial credit if you don't know
Yeah.
what you did.
Some of you guys have been hurt by just putting the wrong answer and not getting any partial credit from me because I had no idea what you were doing. All right, let's take a look at number 24. I'm going to jump around a little bit. 24 says, you are given the secant of theta equals negative 4/3. And theta is in between 90 degrees and 180. So they're telling you that you are in quadrant 2. Okay, secant's annoying. What can I do with secant of negative 4/3 to make it less annoying?
Flip it.
Flip it, and it will then be
It will then be
Cosine.
cosine.
cosine of theta. The reciprocal will be negative 3/4. Okay, so I'm looking at a triangle. Actually, I only need cosine of theta. I don't need any of the other ones for this, because the directions on this said find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Oh, and I will need the other ones for these. This isn't a half angle now, it's a double angle.
And it isn't a 3, 4, 5.
Nope. That's a little trap they set for you. It looks like
Yeah.
an Easter egg, doesn't it?
Because the 4 is the
The
hypotenuse.
4 is the hypotenuse, negative 3 if we're on the unit circle. Can I go ahead and have a negative adjacent leg? And then my opposite leg is going to be the square root of 4 squared minus negative 3 squared, which is the square root of 16 minus 9, correct?
Yeah.
Which is the square root of 7. Did I do that right? Please double check my arithmetic. I'm not having the best arithmetic day yet.
It looks right.
Okay, so I do need to know that the sine of theta is square root of 7 over 4. Is the sine positive or negative on this triangle?
It'll be positive.
It will be positive. For one thing, according to my drawing, it's going up. It's not going down. For another thing, we know we're in quadrant 2, where the sine is always positive. Okay? I think I have enough information here, because sine 2 theta, we said yesterday, is just 2 sine theta cosine theta, correct? So that will be 2 times the square root of 7 over 4 times negative 3/4. So that is going to be negative 2 times 3 root 7 over 16. Is that correct?
Yeah.
The 2 and the 16 can reduce with each other, and I'm going to get negative 3 root 7 over 8. And that should be the sine of twice. Remember, we're talking about this angle over here. That's my theta. Did we do the half angles by accident when we were going over this earlier, Tim? Okay, so we found these half angles.
Yeah, and then we stop.
Okay, so, that was when we were. All right, any questions on this now?
It is. Secant.
It gave us the secant,
Gives.
and it's asking for the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta.
That's
Keep in mind, we're not finding out what theta is. We don't know what that angle is. We know it's in quadrant 2 because they tell us, and that's a good place for a negative secant and a negative cosine to be. We know if we double this, whatever it is, it's going to be somewhere where we get a negative sign. Let's find a cosine of 2 theta. I gave you 3 identities for cosine 2 theta yesterday. 2 theta yesterday. Cosine squared minus sine squared. What were the other 2?
Wait, what were they?
2 cosine squared theta minus.
2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. They should all wind up being the same thing, though they may not all look the same. Who has a preference? Which identity? Should you use the top one?
Yeah.
Okay, good. So cosine squared is negative 3/4 squared. minus sine squared, in this case, is positive root 7 over 4 squared. So I'm getting positive 9/16
Yeah, minus 7/16.
minus 7/16, so 2/16 or positive 1/8. I got a negative sign when I doubled this angle, and I got a positive cosine when I doubled this angle. So when I doubled this angle, in which quadrant did I find myself?
No, wait. 4.
Very good, 4, because that's where the sine is negative and the cosine is positive. On the unit circle, remember, cosine's x, sine is y. We're literally at the point 1/8 negative 3 root 7 over 8 on the unit circle, which with a positive x and a negative y means we're in quadrant 4.
Negative 3 root 3 and negative 3 root 7.
Thank you, thank you, thank you. I think I said it correctly, but
Yeah, you said it correctly.
awesome, okay. Tangent of 2 theta.
There's just one over the other.
Yeah, should I pull out a formula for this?
No.
No. Heavens no. I'm just going to put the sine, and I'm going to give myself a little more room here, for the tangent of 2 theta. I'm just going to put my sine of negative 3 root 7 over 8 on top of my cosine of 1 over 8, and that will just be negative 3 root 7 when I'm done simplifying that fraction. So that's how I use these identities. All I know is the secant originally of some angle in quadrant 2, and just from that information I can find the sine, cosine, and tangent of double whatever that unknown angle is without ever finding out that angle. You guys can imagine how powerful this was for solving problems, engineering and other mechanical problems in the pre-calculator days, when you couldn't just pull up a calculator, or if you go back far enough, even a table that would have all of your inverse signs. Because let's face it, if you really needed to do this in a hurry for an engineering problem today, you would go to the cosine theta equals negative 3/4 step, you'd pull out your calculator, take the inverse cosine of negative 3/4, and then you double whatever angle you got to find these. But this was very, very powerful tool back before that existed. Any questions on number 24? Going once? Nate, if I were you, I wouldn't try to do any of these steps in your head. You're very good at that sort of thing, but I know you like to, but seriously, there are too many places to make mistakes here, and I won't be able to figure out what you
And
did.
there's no calculator on the test.
You'll have a couple of these with no calculator, correct? That's the whole historical point of these.
You're kind of fun though.
Aren't they? They're kind of puzzle-like.
Yeah, I mean, like, these, I don't know, I just kind of like,
My heart just grew 3 sizes, Danny.
okay, can I get extra credit?
Maybe a little bit for your participation grade. All right, let's take a look then at number 26, because I think that was more annoying than number 22.